You guys can still answer questions, but just make sure you're with me, paying attention. Writing what I'm writing, unless you have it. Okay? Number one here, guys. This is just a unit rate. How do I know it's a unit rate question besides the fact that the instructions say it right there? How do I know that? Yeah? Yeah, whatever you're trying to figure out a per something, we know that's a unit rate. Okay? That's always going to be unit rate. So what do you have to do whenever you're finding unit rate? What do you actually have to use to find the unit rate? You have to do this. If you didn't do this, it is wrong. Kaden?
Proportion.
You have to do a proportion. So everybody, if you don't have this, right? If you don't have this, go ahead and put an X through it because it is wrong. Okay? It's wrong if you don't have this. So now we're going to put a 1 right there because we know it's unit rate. We know that unit rate goes in the bottom right of every... Is that a color pencil? Bottom right of every unit rate proportion. Since it says per hour, that means 1 hour, so that's how I know that hours is going to go there. Hours is going to go there, which means miles is going to go there. Miles is going to go there. What do I call this right here?
Fake ratio.
That's our fake ratio. And we go ahead and put that on the left one, so 6/2. What are we doing to our number of hours here? We're dividing by 2. So then we've got to divide our miles by 2, which is going to give us the answer 3 miles per hour, which means, that makes sense, if you travel 3 miles every hour, that will mean that you will travel 6 miles in 2 hours. So those are equivalent, and the answer is B. But I'll say this once more, guys. If you do not have this tomorrow, I will count it half off. Some people think I'm being picky. Well, maybe. But that's the way I want it done, and it's mainly because I know where we're going. I think most of you are realizing, well, why can't I just do 6 divided by 2? Yeah, you can. But I know what chapter 5 is, and I know how important proportions are for 5 and 6, so I'm getting you in the practice of doing them. So if you didn't have that, put an X through it. It's wrong. If you don't do it tomorrow, it will be probably half wrong. I'll give you half, but still, you get halves on everything. That's 50%. Okay, let's go on to number 2. Okay. All right, same kind of question here. Again, we know this is a unit rate because it automatically says the amount of, or how much does it cost per pencil. So we should have a proportion. We should put 1 there. Now, since it specifically says per pencil and not per dollar, that tells me that I need to put pencils on the bottom. I need to put dollars on the top, dollars on the top. Okay? And then I know it's going to be $2.40 for a dozen, which we know is 12. So really the fake ratio is $2.40 for 12 pencils. So there's our fake ratio. We know that we have to do the same to the second term as we did to the first term. So 12 pencils divided by 12 pencils is going to give me 1 pencil. Now, over here, the real important thing that you really have to pay attention to that students get confused is they forget whether to do $2.40 divided by 12 or to do 12 divided by $2.40. Those are not the same thing. You cannot flip the order. They don't have to put them in. Yeah, tell them. Those aren't calculators, these are. But yes. Okay? So, they are not the same answer. You cannot flip the order of a division problem and get the same answer. Okay? So, we have to do it left to right like it's showing right here. It is specifically saying $2.40 divided by 12. You have to keep it in that order. Now, we'll go ahead and bring this up. $2.40 divided by 12 is going to give us 0.2. Now, if this were a short answer question, if there were no answer choices, and you left your answer as 0.2, I will count it half off tomorrow. Okay? Money goes to 2 places whenever we're talking about money. 2 places to the right of the decimal. So that means you're either rounding to here, or if your number stops there, you've got to add a 0 there. 0.2 is not an amount of money. 20 cents is. So even if you were able to go, oh, well, I know the answer. Whoops, I didn't want to erase all that. I know that the answer is going to be 20 cents per pencil, and you selected C, I guess that's fine. I would accept that since it's multiple choice. But because, or if this wasn't multiple choice and you left it as that right there, I would count it half off. We need to start being able to work better with money and understanding how to round money or how to add zeros in this case, okay? Everybody got that? So the answer is 20 cents per pencil. It would be a 0 on there. That would be the answer. If you wanted to check your work, you could say, well, if I know that one pencil is 20 cents, can't I do 20 cents times 12? What should it give me if I multiply it by the 12 pencils? Yep. It better give me what I told you 12 costs up there. So it's a little way to check yourself there. So again, if you got the answer right, great. But if you didn't show this proportion, it is wrong. Okay? And if you don't show the proportion tomorrow, it will be half wrong. All right. Which ratio is not equivalent? There's a couple ways you can do this. I taught you the big three methods, right? We'll work with those now. We got the big three methods. Okay? Does anybody remember the first of the big three methods? We're going to come back to this here in a little bit. Noah?
You can do simplify.
You can simplify them, absolutely. So I try to simplify 4 to 7. I'm going to find out that's already in simplest form, right? So I'm going to go through here, and I'm going to go ahead and simplify all these now. So 8 over 14, I know they share a factor of 2 and a 2. That's going to give me 4 to 7. Are they the same simplified ratio? Yep. 7 to 11. Is there anything I can divide 7 and 11 by? No, they're both prime. So that one is in simplest form. So right now, that's different. 24 over 42. I know that those both share a factor of 6. And that's going to be 4 to 7. Oh, that's the same. And then finally, 40 to 70. You know they both end in 0, so they must share a factor of 10. And that's going to give us 4 to 7. There we go. We have 3 of them that equal a simplified ratio of 4 to 7. One of them does not. Now, that's one method you could have done it. The other way you could have done it is by just dividing, because all ratios are division problems because we're treating them as fractions, right? Okay, so if you would have done that, you would have to do 4 divided by 7. 4 divided by 7, which is going to give you a big long list of numbers. So we can just round it to like right there, 0.571. So that equals 0.571, right? So then if we went through and did it on all of them, we better get that same answer. So here we go. We'll do 8 divided by 14. Did it give us the same answer?
Mm-hmm.
Yes, it did. Okay, we'll do 7 divided by 11. Did it give us the same answer?
No.
No. So we already know that's the one, but we'll keep going just to make sure. 24 divided by 42. Always top number divided by bottom. Is that the same as the other one?
Yes.
Yep. And then 40 divided by 7. D. Same number again. So that's the other way. The other way that you could do it is called cross products, right? The only issue that I have with cross products here is you would have to do it for all of them. You'd have to do 4 to 7 and 8 over 14. Cross products there, 56, 56. Okay, that one's good. And then you'd have to do it for all of them, right? I don't care as long as you showed it. You had to show me something proving it. You had to show me the simplified ratio. You had to show me what it equals after a division problem. You had to show me something. You could not just circle the letter B. Everybody got that? You had to do something. Did everybody hear me?
Mm-hmm.
You had to show me. You didn't have to show the dividing. I don't care about that. I'm just saying, if you showed me that this equaled 4 to 7 and the other ones did not, then it's fine. Yes?
What happens if you did on the calculator, but you didn't write any of them?
I'll accept it.
Oh,
I'll accept it. Yes. All right, let's keep moving. Second. All right, let's go down to number 4 down here, 4, 5, 6, and 7. Okay, I'm going to zoom out. Now, these were matching. It was a little confusing how it was laid out, but you just had to match these terms up here to these definitions. So the first one here, this, by the way, this is all on the Quizlet. I don't know if anybody used it, but it's still there. There's really, you know, this same exact question is going to be on Sunday. Same question. So if anybody missed it, you know, it's going to be basically shame on you, because if you're missing this when I'm telling you it's going to be there, that's a little bit of a problem, right? They're just definitions, 4 definitions to memorize, and realistically, a couple of them you probably already know. A ratio where the bottom term is a 1. Anytime you're doing per 1 of something, what are we talking about here, guys?
Unit rate.
We're talking about unit rate, so that would be letter V. Okay. Number 5, equal or the same. Well, there's the root word right there. So that makes that one pretty easy, right? Letter D. Over here, a comparison of two numbers by division. Anytime you're comparing two numbers by division, we are talking about ratios. And then finally, the numbers that are being compared in a ratio, those are called terms. So whenever we have the ratio 4 to 7, 4 is a term, 7 is a term. So if you hear me refer to this as the first term or this the second term, that's what they're called. It's not a numerator or denominator because they're not fractions. It is a first and a second term. All right, let's move on. Okay? Okay, there are 4 stars and 3 balloons. So right now what I'm going to do is I'm going to just do edge pieces because that's my fake ratio. So if you didn't do this, you might want to just so you have it. We know that there are 4 stars. We know that there are 3 balloons, which means there are 7 total, right? Okay. Anna, let's think about what Anna's saying here real quick. Let's do her edge pieces. Anna is saying that the ratio of stars, and I'm going to use a highlighter here to help us visualize it, stars comes first, and she had 4 coming first. Then she said 2 balloons, and then that came second, so did 3. What?
Yeah, there's a 2.
No, I meant stars, 2 balloons. Okay, sorry. So we know that the stars goes with 4, the balloons goes with 3. So let's write down what she's finding out. She knows there are 4 stars, there are 3 balloons, there are 7 total. Okay, let's write down what Billy is saying. Okay, Billy says that the ratio of stars, so he gave it in the same order as her. I'll leave it the same color, stars, but then he gave 3 first, and then he did balloons second, but he gave 4 second. So you see they both used the word order the same, didn't they?
Yeah.
But then one had the numbers flip-flop, so let's write down what he's saying. He's saying there are 3 stars, 4 balloons, and 7 total. So first off, let's determine who is correct. Who is correct here? Billy or Anna, number 1, yeah? Anna is absolutely correct. And then, okay, so that's part of this answer. But you then have to explain. It says who is correct and why. So you had to write a sentence, or not really a sentence. What did I tell you? What response am I perfectly okay with here as far as whether or not you can get it right?
Order matters.
Order matters. That's all I need. Now, if you went into a long paragraph of saying, well, Billy is saying that there are only 4 stars, or that there are 4 stars and 3 balloons, whereas Anna is saying that there are 3 stars and 4 balloons, which is correct. By the way, just so everybody knows, you will have this same question on the summative once again, obviously. Okay, only it might not be Billy and Anna, it might not be balloons and stars, but it'll be the same type of question. Let's go on to number 9. Okay, these are going to be pretty easy here. It says the ratio of boys to girls in Miss Brown's class is 4 to 5. Since it's talking about boys to girls, these boys do not in any way make up the amount of girls there are. So therefore, they're 2 totally different parts. So this is going to be a part to part. Now, if it would have been boys to total students, then yes, it would have been a part to whole. Here's what I want you guys to do. At the bottom, I want you to put how many questions you got correct out of 9. So if you got them all correct, you got 9. If you missed 1, you got an 8. If you missed 2, you got a 7. And then go to the next page. Here we go. Next page. Okay. The top one here. We're going to go real quick here. It says a bag is filled with M&Ms and Skittles. There is a ratio of 25 Skittles out of 65 total pieces of candy. Do those 25, are they included in the 65?
Yeah.
Yes, they are. That is absolutely a part-to-whole ratio. Because it gave you, and plus out of kind of gives it away, right?
Yeah.
That's always going to be a part-to-whole. Let's keep going. Okay, number 11. Write the unit rate and then explain which unit rate makes more sense. Well, it says right here how many pens per dollar. So you had to do a proportion, first of all. If you didn't do a proportion, mark it wrong right now. Okay? Now, since it says per, we know we're doing unit rate. And since it says per dollar, that means this one, number 11, you had to put dollars on the bottom. If you didn't have a proportion, and if you didn't have labels, it is wrong. Okay, I would take off half points on the summative. For the formative, it's wrong. Okay, so now we know dollars are on the bottom, pens are on top. If if you flip-flop 11 and 12, you're going to mark them both wrong because you're not answering the appropriate question. So, did I skip number 10? Am I on the right one? Okay, I did 10 though, right? Okay. All right, sorry about that. Okay, so how many pence per dollar? So now what we're going to do is we're going to take our fake ratio right there, and we're going to put it on our proportion. So it's already set up the right way for us there because pence came first, $5. What are we doing to our number of dollars there? Dividing by 5, so what do we got to do here? Remember, we have to leave it in the order that it's given there in our left to right, so we're going to do 8 divided by 5. I got it right now.
And then you'll get 1.6.
1.6. Okay, so that's 1.6 pence per dollar. Okay, we'll talk about that more here in a minute, but you had to have that. If you didn't have that exactly, mark number 11 wrong. Okay, next one, what is the price per pen? Now what we're going to do is we're going to put 1 there, but now we're talking about per pen, so pens are on the bottom. Money is on the top. We're going to use the same fake ratio, obviously, only we've got to make sure we keep the labels with the correct numbers. Now that money's on top, we've got to do the, not really a reciprocal, because we don't have reciprocals of ratios, but if you're thinking of it as a fraction, that's what it is. So we know that we put pens on the bottom. Now we are dividing our number of pens by 8, so we have to divide our number of dollars by 8. So now we're going to be doing 5 divided by 8. Pull out my calculator. Have to do it in that order. 5 divided by 8 equals 0.625. Now I'm going to write this up here real quick. Now this is money, right guys? Okay, so this is an amount of money. How many places did I tell you money goes to, Ayush?
3 places.
No.
2 places.
2 places. So if you were to take your scissors out and just cut it right there, you wouldn't just say, okay, that's 62 cents. Because we've got to use rounding rules. Now what you can say is, I know this is either going to be 62 cents or it's going to be 63 cents. Those hundredths or pennies, which is what those are either going to stay where they are at 2 or they're going to go up to 3, right? And what is it going to do here? It's going to go up because this is 5 or more, so we raise it up. So that's going to be 63 cents. You could have just put 0.63 or 0 and 63 hundredths. I don't care what you did there. Okay, so some of you might be saying, why are you counting this wrong if you flip-flop these? Because some of you have these backwards. Well, because we have to answer the appropriate question. And since the question says how many pens per dollar, you need to answer that question. So if you put this, you're not figuring out how many pence per dollar, you're figuring out how many dollars per pen. So you're going to miss 11 and 12. All right, now, we know what this means. This means that I can go into a store, I can throw down a dollar bill, and they could give me 1.6 pence. Doesn't really make any sense, right? But that's what it means. Agreed? Or, on number 12, you're learning that it's going to be 63 cents per pen. So if you wanted just 1 pen, you didn't need 8 of them. You just needed 1. You'd have to come up with 63 cents. Does that make sense? Sure, absolutely. This one is, the pens, the cost per pen is always going to make more sense because that's the unit price. Because you can always do partial money, okay? You can't always do partial items. Everybody understand that? Yes? Pence per dollar? No. It's not about being easier. It's which one makes more sense. You can't walk into a store and say, "Hey, here's my dollar. Give me 1.6 pence." Now, some of you might say, "Well, I could get 1 pen." Yeah, I get that. I understand that. But I'm trying to say which one of these 2 unit rates makes more sense. Now, I'll give you an example. What if this were? Don't write this, but I'll give you a quick example. Let's say this was 10 pence for $5. Now, wouldn't that give us 2 pence per dollar? Okay, now which one would make more sense? They would both make sense equally. Everybody understand that?
Yeah.
They would both make sense because you can go in, give them $1 and get 2 pence, or you could go in and buy 1 pen for 63 cents. Actually, it'd be 50 cents if I were doing that same fake ratio, but that's that. So yeah, it would be, number 13 would be cost per pen is going to make more sense. All right, number 14, you had to show 2 methods here. I will show all 3. If you do not know all 3, you might want to write this so that you have it for the future. What's the first of the big 3 method? Who wants to remind me? And I personally think it's the easiest. Elizabeth? You can simplify. That's perfectly fine. What's the next of the big three methods? Marina?
Divide.
You can divide them because all ratios are division problems. And what's the third one? Alina? You can do cross products, right? So let's go through and do those now. So simplifying, if I were to simplify 8 to 10, I'll bring it down here and do it. I know that those both have a factor of 2, and that's going to give me a 4 to 5 ratio. I know that 24 and 30, and you could go off to the side and do your trees and actually find the greatest common factor. You could do it that way. I know that it's going to be 6, which is going to give me 4 to 5. So based on our simplifying, are they going to be equivalent, guys? So far it's yes. Okay, now let's go ahead and divide them. If I divide 8 divided by 10, I'm going to get 8 tenths. 0 and 8 tenths. If I do 24 divided by 30, I'm going to get 0 and 8 tenths. So based on the division, are they equivalent?
Yeah.
Yes. Now we'll do cross products. That's where we multiply them diagonally. 10 times 24 is 240. 30 times 8, drop the 0 off. 3 times 8 is 24. Add the 0 back on, gives us 240. So based on cross products, are they also equivalent?
Yep.
Okay, there we go. So we just proved it 3 ways. You had to show 2 of them to get it right. If you did not show 2 methods, it is wrong. Okay, so when I say show your work, you didn't have, I don't care really if you showed me this. All I care is that you showed me them both being simplified. If you showed 4 to 5 written twice, perfect. That's one method. If you showed it equaling 240 being cross products there, that's one method. If you showed it being divided, I'm not saying I want you to do this. I don't care about this. That is, we're past that. We've moved on. Okay? You just had to show me what it equals after you divide. Yes. And there's a fourth method that, remember I always say the big three and the little fourth? I call it the little fourth because it doesn't always work. This one actually does. You can see that you are multiplying the top and the bottom by the same number. So that would work there, but that's not always going to be one we can use. Everybody got that?
So that still counts.
That's fine. There are 4 methods for this one. But guys, the little fourth method, I wouldn't rely on it. I would learn all 3 of these ones to make sure that you know it. Because that method right there will not always work, just sometimes.
Isn't that, fourth?
Good. All right. Let's keep going. Let's go down and do, number, is it down or up? Okay. Go up here. Go over to number 15. Okay. Here we have the ratios. Now the first thing I did is I rewrote them in fraction form. Okay. So it is going to end up being no. Now let's go through the methods here. We have cross products. We have simplifying. We have dividing. So let's do it. Cross products, if I do that, that's going to be 5 times 5 is 25. 6 times 4 is 24. Based on that information, is it a yes or a no?
No.
It is a no. If I were to simplify these, guess what? They already are in simplest form. If they already are in simplest form and they're not the same, then it's a no. Right? And then, finally, if we're ready to divide them, I know that this one, 4 divided by 5, would give me 8 tenths. 5 divided by 6 would give me 0.83 repeating. 0.83 repeating. Are they the same, guys?
No.
So it is no. That one there would absolutely be no. You had to show me 2 out of 3 of those methods. Got it? Just understand, guys, if you're not counting it wrong now, and when I'm not going to go through with these, and if you're not being honest with yourself and on the summative tomorrow, if you don't show me 2 of these methods, it will be incorrect. I will not accept it. Now this one, I wouldn't want you to say, oh, well, there's nothing you can multiply by, because I don't want to rely on that method. Okay? If it's one where you can actually see it being multiplied times 3, that's fine. Let's go down. Okay? Simplify method first. We'll do that first. I know that 8 and 12 have a factor of 4, so that's going to be 2 to 3, right, guys? I know that 6 divided by 9 6 and 9 share a factor of 3. So I do that. So far, is it a yes, guys?
Yeah.
That's one method you had to show me. Another method, you could divide them. Okay, 8 divided by 12, that's going to give me 0.6 repeating. 6 divided by 9, that's going to give me 0.6 repeating. So based on that, is it a yes or no?
Yes.
And then finally, the last method here, you could use cross products. and you would get 72 for both of them. So then CP would be a yes. So you had to show me two of those methods. Remember, you do not have to show me the division or the simplifying. You just have to make sure that you show me what it equals, what the division equals, or what the simplifying equals, or what the cross products equal. All right, let's keep going. Find the missing term. I'm not going to count off for this if you didn't do this, but I would like you guys to write it if you didn't do this. Who remembers what I told you to do when we first practiced this in class? Anybody remember? What did I tell you to do with both these types of questions? Anybody remember? Okay.
Divide,
Nope. Not before that. Before that. Josh? Put them in fraction form. If you didn't do that, it's fine, but I would like you to do it now, please. I think, in my opinion, it's easier to see it when you put them in fraction form. I think it just makes it a little easier to be able to see that the answer is 20. Okay? So that's all you had to do. You didn't have to show me anything else, but just remember for tomorrow, if you miss it, you don't do this, I'm probably going to, I don't know why you wouldn't. It took me literally 5 or 6 seconds to do it real quick. Just helps you out a little bit. Okay, this one here, same way. I'm going to do my first ratio, 64 to 40, equals 8 over blank. What am I doing to my 64? I'm dividing it by 8, right? So what do I have to do to 40? Divide it by 8. That's going to give me the term 5. Okay? Again, if you didn't have this, it's not wrong, but I would like you to please write it because I just think it makes it a little easier on you. Okay, simplifying. You had to write each ratio in simplest form, or as a fraction in simplest form. So we have the ratio 42 to 56, or 42 out of 56. Over with. Okay, if you're sitting here trying to figure out what these divide by, you could just say, well, they're even, divide by 2, or I know 4 plus 2 is 6, which is divisible by 3. 5 plus 6 is 11, is not divisible by 3. So you might just have to start with 2. So if you did start with 2, that's fine. You would end up getting 21 over 28, right, guys?
Yeah.
Hopefully we don't, what? Yep, and then you would have to realize that one of them is odd, so you've got to check 3, 5, and 7. As I just said, 2 plus 8 is 10, right? It said 5 plus 6 is 11. Either way, it's not divisible by 3. Neither of them end in 5 or 0. And then 7, you just got to kind of check. You would be able to divide by 7 to both of them to give you 3, 2, 4. Okay, some people stopped at this one right here and said that was simplest form. You had to put it as 3 to 4. Guys, you can always, as I said a minute ago, you can always find do your trees, find the GCF. It would end up being 2 times 3 times 7, and 2 times 2 times 2 times 7. You would have gotten a 2, you'd have gotten a 7s. That makes your GCF 14. Makes sense. You can either divide by 2 and then divide by 7, or you can divide by 14 once. You see how those numbers go together there? 2 times 7 is 14. That's fine. Doesn't matter the order in which you do it as long as you got to right there. Okay, this page is going to be out of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So everybody put the number you got correct out of 10, please. All right? All right, this one here. You had to do the same thing as you did on the previous page, 15 to 10. The one mistake that a lot of people were making. Yeah. And I just haven't gone through it. It's all right. Whoa. All right. A lot of people were converting this into a mixed number. I saw people doing that. This is not a mixed number. These are ratios, comparison of two numbers by division. What factor does 15 and 10 share? Yeah?
Oh, 3.
No.
Oh, sorry, 5.
Yep. And then you're going to end up getting a ratio of 3 to 2. I will not accept 1 and 1/2. No. These are mixed numbers. Okay? We are talking about ratios. You had to have 3 to 2, and that's it. Okay? Yes.
What happens if you put the one?
If you put 1 and 1/2 anywhere on your paper, even if you had this written, it is wrong because that's a misunderstanding that we want to correct. And it's going to be wrong tomorrow, so you may as well get it thinking that way now. All right, the ratio of Harry's money to Lincoln's money is 6 to 5, as you can see here from the model. You can see there are 6 equally sized squares for Harry and 5 equally sized squares for Lincoln. Okay, then we get to the if statement. That's where your real information is going to start, right? This up here is just your what information, guys? That's just your fake stuff, okay? So, we know that Harry and Lincoln have a total of $715. So, remember, the goal to every single bar model that we're ever trying to do is we're trying to figure out how much one square is because they're all the same size squares, right? Everybody got that? So, we've got to figure out whether we're doing 715 divided by 6, 715 divided by 5, or whether we got to do it by the whole, which is divided by 11. Okay? Since this is their total money, and they have a total of 11 squares, and as you can see the little, what do you guys call this, the teacher squiggle or something? That's what you guys called it. Okay, the teacher squiggle is representing both bars. We know that we have to do the 715 divided by 11 because there are 11 total of them, which I think gives us 65 in each one, right?
Yeah.
Okay, then if we're ready to answer the question of how much money Harry actually has, well, we know that he has 6 groups of $65, so we've got to do 65 times 6 to give us $390. There's your answer. Okay? If a lot of people just stop it, there's no question to be asked here. Okay, the answer is 390. No, it's fine. As long as you understood 390 and how you got it, that's fine. Okay, this one down here. Now we're using the same fake ratio, but we get different real information. Now what people are getting confused on, this is now over. Okay, this the fact that they have $715 combined, that's done now. I had some people that were using this information and saying, oh, well, I'll just do 715 minus 575 and get my answer. No, they're two totally different questions as far as the real information goes. Okay, this one up here is saying if they had a total of this, then how much does Harry have? Then it says, okay, if Lincoln has this, how much does Harry have? So once again, you have to look at it, looking at the model, we've got to figure out how much would be in one square, how much money. So since 575 is only representing Lincoln's money, we need to divide that by his 5 squares, which is going to give us, is it 115?
Yep.
115 in each square. So that means each one of these little squares is $115. And then we've got to do 115 times Harry's 6 squares, which is going to give us 600 and what? $690. Okay? All right. Number 23. Use the table to write the ratio of green beans to peppers in 3 different ways. Let's first of all just figure out the order here. So it says green beans first. So that means I'm going to highlight it like this so we kind of know. Okay, it gave me green beans first. It gave me peppers second. And there we go. We know it has to be green to yellow. So we were going to go 37 to 30 in fraction form, right? We're going to do 37 with a colon, 30. And then the last one will be word form, which is when we use the word to. Or the word for, F-O-R. I would accept that as well. Okay, but most of you probably did it like this. So you had to have all 3 of those. It's either right or wrong. There's no half points, none of that. Number 24. You had to write the unit rate in 2 different ways. So the first thing you need to understand is you have to have 2 separate proportions here. Everybody got that?
Yeah.
Now both of them are going to have 1 in the bottom right. Right, everybody? Okay. So I don't care which, since there's no question, it doesn't say, well, how many Skittles can I get for $1? Or how many, I guess, how many bags of Skittles? Or how many bags of Skittles can I get for $1? It doesn't ask how many dollars can I get for, or how much does it cost for 1 bag of Skittles. It doesn't ask those questions. So it doesn't matter if you have these flip-flopped as far as one over here. It doesn't matter which side they're on. Okay? So I don't care what you did. I just know that I have to figure out per bag, and then I got to figure out per dollar. So I'm going to do the per dollar over here, I guess, which puts bags on the top, bags on the top. You had to have labels. If you didn't, it's wrong. Okay? And then this one we're going to have to do per bag. Per bag. So then we're going to put dollars on the top, dollars on the top. All right, we got our unit rate proportions all set up and ready to roll. Now we just have to use our fake information to build our proportion. So over here, bags I know are 15, and then I know that the cost is $22.50. Okay, over here I know that money is now on the first term, the top, so it's going to be $22.50 for 15 bags. So over here, what am I doing to my amount of money? I'm dividing by $22.50, and then I've got to do the same thing over here, dividing by $22.50. Now, cool, I'm going to do it just so we all see it. Just make sure we're doing this left to right. Order matters when you're dividing. So we're going to do 15 divided by 22.50. And there we go. And again, remember that 7 is just because the last digit's rounded up. That means 0.6 repeating. Okay? So I'm just going to just put it, you could have written it like this. If you rounded it to 0.67, 0.667, I'm fine with any of those answers, okay? Depending on how you round. I think I said at the beginning of the test, I'd like you to round to the hundredths. But if you left it as 0.6 with a line over it, that's perfectly fine. Okay, now over here, I know I'm dividing my number of bags by 15. So I've got to divide my money by 15 as well. So now we got to do the opposite division problem. We have to do 22.50 divided by 15, and that's going to equal 1.5. Now, if you left it as 1.5, it is wrong. Okay, we are talking about money. If you left it as 1.5, it is wrong. You have got to understand, just like we talked about earlier, money goes to two places. You can't just stop here and say, yep, that's $1.5. There's no such thing as $1.5. It would be $1.50. Okay? Now, let's talk about what these mean. This one over here means that for $1, if I walked into Meijer and I had only $1 in my pocket, I could go to the cash register and say, here's $1. I would like my 0.6 repeating bags of Skittles, right? Or you can walk in there and say, how much is it going to cost me to get one bag? They'd say $1.50. Which one makes more sense here, guys? Which one's going to make more sense? Josh? This one here is going to make more sense. So first of all, you had to circle it or explain it, and then I'm not even. I mean, as long as you just circled it here, I'm going to accept that. I'm not going to make you do an explanation. If you did, good job. I hope you said something about the fact you can't buy partial bags of Skittles, but you can have partial money. You can have, cents. That's why we have coins. So on the back here, this page is going to be out of 1, 2, 3, 4, 5. So that puts the whole thing out of 15, 24. So I would like you guys to figure out how many you got correct out of 24.